So today we're going to talk about called slope fields. These are actually pretty easy. Remember when you're in school and you play with magnets and little iron filings? Like if you stick a magnet under the paper and pour the iron filings on top, it would like make the shape of the magnet. That's kind of what a slope field is. It's you a derivative of a function and you use it to draw what's called a slope field. And when you're done drawing it, the shape that you see in the slope field should tell you kind of what type of function this would be the derivative of. So we're going to kind of try to make, it's going to look like the little iron file, like all these little lines that together, when we put them all together on this slope field, will kind of show us what shape function has this as its derivative. So I'm going to show you how to make them, and then we'll kind of interpret what we see in the slope fields when we're done making them. But they're pretty easy to make. They're kind of tedious, so I don't want to look for patterns, but they're hard to make. So remember, dy over dx means derivative, and derivative means slope. So you have to have a derivative of a function of slope. An equation that's a derivative is called differential equation. You can take a whole class in differential equations in college that math nerds call DiffEq. So if you like differential equations, you can take DiffEq in college. I did not take it. I wish that I had. Differential equations are kind of my but so let's look at how to solve this differential equation. So what you do is you go to each point on the graph and plug in the x, y coordinates into this function. Now in this case, this only has x, so really have to for each point is plug in. So I'm going to here in the middle at 0, 0. If I plug 0, 0 into, really I'm just plugging in the 0 for the x. 0 plus 1 would be 1. So I'm going to draw a little line right through this point that has a slope of 1. That line will just kind of represent what the slope is at that specific point. So remember, a line with a slope of 1 would point up 1 and over 1. So I'm going to draw a little line that kind of points, I keep forgetting that kind of points up 1 and over 1, like this. And in fact, any point that the x is 0 will have a slope of 1. So when I do each point, I want to look for a pattern that will let me do a whole bunch of points all at the same time. So I know that any point that has an x of 0, 0 plus 1 will be 1. The slope will be 1. So every point that has an x of 0, that would be all of these points on the y-axis. 0, 0, 0, 1, 0, 2, 0, negative 1, 0, negative 2. They will all have a slope of 1. I'm going to draw lines that have little slopes of 1. And you don't have to be exactly perfect with your slopes. Maybe you're going to, is the steepness, right? 1 is not very steep, and that it slopes the right direction. It is a positive slope, so it should slope up and to the right. But they're not going to get real nitpicky about if it's exactly 1 perfect. You just want to kind of get it right. So then I'm going to pick another x value. I'm going to go over here to where x is negative 1. And so all of the points where x is negative 1, negative 1 plus 1 would be 0. So all the points where x is negative 1 would have a slope of 0. So that'll be just a little horizontal line. And then I'll go to where x is negative 2. All of these points have an x of negative 2. And negative 2 plus 1 would be negative 1. So I'm going to draw a bunch of little lines that have a slope of negative 1. Right. Just the opposite of the ones that had positive 1. These point down 1, left 1. Right. So they're not very steep, and they point down and to the right. I meant down 1, right 1, not down 1, left 1. And then all of these, where the x is negative 3, the slope would be negative 2. So it should have negative slope and be just a little bit steeper than these lines. It should point down 2 and right 1 instead of down 1 and right 1. So it's a little bit steeper. And they could do the same thing going the other direction. All the points where x is positive 1, the slope would be positive 2, so a little bit steeper. Then all the points where x is positive 2, 2 plus 1 would be 3, so it would be positive 3, which is a little bit steeper. And then where x is positive 3, 3 plus 1 would be 4. That's a little bit steeper. So do you see a shape in this slope field that looks familiar? This is actually showing you what's called a family of solutions. Because remember, if we were to actually try to solve this equation by integrating, we would end up with a plus c, right? When we integrate, we have to put plus c. That plus c means that we don't know vertically where the graph is. So the graph could be up here, it could be here, 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 we don't know which one. But if you pick one of those as a place to draw the graph, then you should see the shape of kind of a parabola in these, right? It's a whole bunch of parabolas that are stacked up vertically. This would be where the vertex of the parabola is, where the slope is 0, and then it opens up from there, right? So you could, sometimes they'll ask you to draw a solution curve. They'll tell you, draw the solution -1. You would dot it -1, and you would just follow the curve. Right? Just follow the slope field. It's kind of like those iron filings on top of the magnet. The magnet's underneath the paper, the function underneath here, and these little lines help you to see what the shape of the function would be. They could tell you to draw in here, so it would be kind of like this, right? Or here, kind of like this, here. Right? You just kind of go between the lines. But these are all parabola shapes. So that was one that just had x in it. So let's look at one now that just has y in it. So let's look at number 2. It just has y. So now instead of all the same slopes being vertical because they have this x, the same slopes will all be horizontal, where they all have the same y. Right? So I'll start here in the middle. When y is 0, 2 times 0 would be 0. So all the points that have a y of 0, which would be all the points on the x-axis, right? 0, 0, 0, 3, 0, those would all have a slope of 0. And then all the points where y is 1 would have a slope of 2. So all these points, 0, 1, 1, 1, 2, 1, 3, 1, negative 1, 1, all these points would have a slope of 2. And then all the where the 2's have a slope of 4, which is pretty steep. And then negative 1, all the y's are negative 1, the slope would be negative 2. And all where the y's were, where the y is negative 2 would be negative 4. So pretty steep and negative. This is a little bit harder to shape it in the graph. Perfect, thank you. I was wondering if he was going to feel better until I go. Oh. So this is actually a graph of natural log, and which side they give you the point on would determine which direction it goes. So if they told you like 0.11, then the graph would be something like this. But if they told you the 0.1, negative 1, the graph would go the other direction. So it just depends on which point they tell you to draw the curve through. But you can see that there's a horizontal asymptote here in the middle. That's what all these 0 slopes are. And then the graph gets really steep really quickly as you move to the right. Right, so it looks something like that, just depending on where they asked you to draw it, right, which point they asked you to draw it through. All right, so each of us just relied on x or y, so it's easy to find the pattern. All the points that had the same x had the same slope when you just have x, and all the points that have the y have the same slope when you just have y. So those are pretty easy to do. Where it gets a little trickier is when you have x and y. So if you look at like number 3, where you have x and y. Right, so x and y, if you add them together, will equal 0 everywhere that x and y have the same number but different signs. So like 0, 0, negative 1, positive 1. If I add negative 1 and positive 1, I'll get 0. Negative 2, positive 2 makes 0. 1 and negative 1. 2 and negative 2. So all the points where the x and y are the same number but different signs would add up to 0. So that's what I always try to do first, kind of figure out where would the slope be 0 or undefined, and then I kind of go from there. So if this is diagonal, it's probably a safe bet that it's had diagonal for the other points too, but we can check and make sure. So if I take points like negative 1, 2, if I add negative 1 plus 2, I get 1. 0, 1, I get 1. 1, 0, I get 1. 2, negative 1, I get 1. 3, negative 2, I get 1. So all of these points on this diagonal have a slope of 1. But if I do 0, 2, or 1, 1, or 2, 0, or 3, 1, those all add up to 2. So a little bit steeper. 1, 2 adds up to 3, a little bit steeper. 2, 2 adds up to 4, so a little bit steeper. 3, 2 adds up 5, so it gets steeper. But on the diagonal, all the slopes are the same. Same thing will go the other way. Negative 0, these would all have a slope of negative 1. Negative 2, 0 would be negative 2. Negative 3, 0 would be negative 3. Negative 4, and negative 5. Right. Okay, so there's 3 more on the side. One that's just x, so it would like to have the same slope. One that's just y, so all the points with the same y's would have the same slope. And then one that's y and x. So you have to be a little bit more careful on that one. You kind of have to go point by point until you find a path. And there's some more that you can practice on the back. You don't have to do all of these. I just put plenty on here so that if you felt like you needed more practice, you could have more practice. Number 1 on the back, we already actually did it the same as number 3 on the front. But all the rest of them are different on the back. So really it's a total of 11 problems because 2 of them are the same. So 11 problems. So there's 8 other ones you can for practice if you want to. But that's all you're doing. It's just drawing in the slope field so that you can get an idea of what the solution curves would look like, what the solution to this differential equation would be. And the solution is just a function that has this as its derivative. All right. So I will post answers to that in just a second. I'm not going to be here for the next 2 days. Ms. Jade Bison is going to be there. Going to love it for the UIL. So I'm just going to leave you some more stuff like this. Like this is easy. No more where you have to draw on yourself. That work that I'm going to do is matching like either an equation to a slope field or a differential equation to a slope field. So it'll be similar to this. So on this worksheet, on the front and the back, there's matching on both sides, but pay attention to what they're asking you to match. On the front, it says, and for some reason, I don't know why, but this worksheet deleted like all the lowercase s's. It's so weird. I don't get it. It never did that before. I've used this worksheet for years, and it's never printed that way. I don't know why this did. But it says match each slope field with the equation that the slope field could represent. So this is not the differential equations. These are not the equations that make the slope field. This is what shape you see in the slope field. So you should see the shapes of these graphs in the slope field. So like for example, what shape is a graph y equals 1? It's just a horizontal line, right? So which slope field looks like a horizontal line? D, right? Then y equals x, that's the parent function for linear functions. It's just a line with a slope of 1. So which slope field looks like a line with a slope of 1? H, right? So these are just asking you to look for which slope field has that shape in it, right? So remember, x squared makes a parabola, x cubed makes kind of this swirly kind of S shape. It's basically like a parabola where the left half goes down instead of up. 1 over x squared does something like this. Sine x makes a snake. Cosine x makes cups. The natural log of x, I think, is like that. So it's asking you to match the shape that you see in the slope field. Right? Then on the other side, this is asking you to match the differential equation that made the slope field. So not which one of these do you see this shape in, but which one of these could you have used this to make. So this is like what we were doing when we were drawing them. Basically, if you were to draw the slope field, which one of these slope fields would it be? So just pay attention to what you're matching. Are you matching the equation of the function that you see in the slope field, or are you matching the differential equation that made the slope field? Right, because they're two different things. And then on 19 and 20, they just ask you, and once again, it deletes all the S's. I don't really know why, but it's so strange.